Let's practice reading solubility curves. So this is a graph of several different solutes. Potassium iodine here, potassium nitrate here, sodium nitrate, sodium chloride, and potassium chlorate. Notice the different temperatures that the water is at, and the amount of water is 100 centimeters cubed. That makes a difference because if we had more water, then it's a different amount that can be dissolved. And then the graph, the lines on the graph tell us how many grams of these solutes will make saturated solutions. So the first type of question is determine the amount to create a saturated solution. So if I were looking at this, how many grams of potassium iodide, and that's going to be this line right here. And so at these different temperatures, these are the amounts that I can see on the left. That is how much would make a saturated solution of potassium iodide. And then it's asking in 100 centimeters cubed of water, which in fact is how much water is in our beaker. So we'll look at the temperature that they give us, 35 degrees. So here is 35 degrees. And we go up to the potassium iodide curve, and then we go to the left to determine how much is going to make a saturated solution. So here's 35 degrees, and then if I go to the left, it looks like it's about 190 grams that would make a saturated solution. And so here we would say 190 grams of potassium iodide saturates 100 grams of water at 35 degrees Celsius. So if I wanted to give the very thorough answer, that's what we determined. That if you had 100 grams of water in a beaker and it was at 35 degrees Celsius, then it would take 190 grams of this solute to make a saturated solution. So when you get a chance, try number 2, try number 3, write down your answers, and at the end of the video, I will show you the correct answers. In this example, we have to scale our amount that makes a saturated solution in a different amount of water than 100 centimeters cubed. So we know this when we read the question and it says how many grams of potassium chloride can dissolve in 250 grams of water. And so because it says 250 grams of water as opposed to 100 grams or centimeters cubed, same thing, of water, then we are going to have to do a proportion in order to solve this problem. So a proportion is going to be needed. And so what we're going to do in our proportion is we're going to determine from the graph how much would make a saturated solution in this much water, 100 centimeters cubed, and then we're going to scale it up to say, well, how much could dissolve in this much water, 250 centimeters cubed. So we're going to look at the graph at the temperature that they tell us to determine this amount. What would make a saturated solution at that temperature in this much water? So the question is for potassium chloride at 80 degrees. So we'll look at our 80 degrees, which is here, and we'll go up to KCl, which is, we're going to look at 80 degrees, and we're going to go up to potassium chlorate, which is this curve right here. So at 80 degrees, when you go to the potassium chlorate curve, we land there, which is going to be 40 grams. So it'll take 40 grams of potassium chlorate at 80 degrees to have a saturated solution. And so that amount, 40 grams, is what we put up here in our proportion. 40 grams of the KClO3, potassium chlorate, makes a saturated solution at 80 degrees in 100 grams of water. Remember, at the bottom, these are both the amount of your water. So now I'm going to solve the proportion for x in order to scale up my amount of water and then how much would saturate this amount of water. So we'll do a cross multiply. So here we get 100x is equal to 40 times 250, and then of course we're going to divide both sides by 100 in order to isolate our x. So x is going to equal 40 times 250 divided by 100. 40 times 250 divided by 100, and we get 100. So this final answer is 100 grams of potassium chlorate will saturate 250 grams of water at 80 degrees Celsius. Now you can pause the video and try number 5, and then we'll go over the answer at the end of the video. We're going to do all 3 of these examples together. Is the solution saturated, unsaturated, or supersaturated? And so to know this, we want to look at our graph, and we're going to plot the point. And if it's on the line, it's saturated. If it's below the line, it's unsaturated, and if it's above the line, it's supersaturated. So those kind of our quick look at how to answer these questions. Let's look at number 6. It's going to be at 30 degrees and 90 grams of sodium nitrate are going to dissolve, and the amount of water is 100 grams of water. So we do not do a proportion. So we just plot this point. We go to 30 degrees, we go up to 90, and our point ends up right here. And relative to the sodium nitrate curve, which is this one, it's below it. And since it's below it, that's going to make this solution unsaturated. So here, 170 grams of potassium iodide is dissolved in 100 grams of water, which is everything on this graph, so that works out. And it's at 15 degrees. So we want to plot our point from 15 degrees, 170 grams, so that makes our point right there. And so relative to the potassium iodide curve, which is this one, it's above it. And so that makes this supersaturated. And then my last example, we're at 85 degrees Celsius, 160 grams of potassium nitrate have dissolved in 100 grams of water, 100 grams of water, so I don't have to do a proportion. And the question is it saturated, unsaturated, supersaturated? So I'm just going to go to 85 degrees and go up to 160, which is about right here. Okay, and let's just say this one lands on the line. And so since 85 degrees and 160 land on the line, we're going to call this saturated. So now you try number 9. See if you can identify, is it saturated, unsaturated, or supersaturated? And then at the end of the video, you can see the answer. So number 10, which of these shows the least change from 20 to 100 degrees? And honestly, you're looking at the thing that has, the least difference between how much can dissolve at 20 and how much can dissolve at 100. So for example, if you look at the sodium chloride, at 20 degrees, we can dissolve about 38 grams versus at 100 degrees, we can dissolve approximately 41 grams. So you can see that even heating up the water by 80 degrees, we can only dissolve about 3 more grams than we could at 20 degrees. As opposed to, let's look at the potassium nitrate curve, that at 20 degrees, we could dissolve about 33 grams. And at 100 degrees, we can dissolve about 242 grams. So look at the difference. We can dissolve a huge amount more if we heat the water to 100 degrees for the potassium nitrate than we could for the sodium chloride. So sodium chloride has the least change in its solubility, and would want to say safely that potassium nitrate has the most change in its solubility from before and after with those two temperature ranges. So now you can try number 11 and 12, and then at the end of the video you can see the answers.